Hello everyone and welcome back to the HIRO model TR-01-A tutorial series. And last time we learned how to use the HIRO library, and today we are going to actually use that to program HIRO to make a new custom program. So by this point in the tutorial series, you should have downloaded the HIRO library, and if you haven't, you can go back to part 3. You can find the library's documentation in our GitHub if you go all the way down here, and here are some useful functions we can use. But before we can use them, there's a little bit of setup. So the first thing we do, and the easiest way to do that, is we have to include the library so we can use all the various functions and classes in the code. So I'm just going to go up here to Sketch, go down to Include Library, and make sure that you're running a new sketch. And I'm going to hit HIRO. As you can see here, we have 3 new lines of code. Include HIRO.h, so that is the library that allows you to create a HIRO object with all associated pins, buttons, and LEDs. HIRO motion library, so that is a library that facilitates HIRO's various pre-choreographed motions, from walking to emotes to exercises. All those motions are built on the HIRO function library, and we'll go deeper into that later. But for a little bit of a sneak preview, Raspberry Pi Pico here uses 2 CPU cores, but for the sake of simplicity, we are only using 1 at the moment, and at the same time there are 8 different servos. So in one of the next videos, we will be going into multi-servo orchestration on a single thread and how the HIRO functions library helps make that happen. Next thing we have to do is we have to define the HIRO object. So HIRO, and I'm just going to call it my HIRO. And you have just defined a HIRO object. It hasn't been associated with all of its pins yet, so we're going to say myHIRO.begin. So what myHIRO.begin does is it says that all these pins associated with the motors, associated with these buttons, built-in buttons and LEDs, we don't have to know what the pin numbers are anymore. All we have to do is refer to them as the right front leg, or left front leg, or back right shoulder, or button A, button B. So you don't need to define anything as inputs or outputs anymore. All of that is taken care of for you. So make sure that you are referring to the right board. So in this case, I'm using Raspberry Pi Pico W. There are other options that I'll plug in. Some of you may have a Raspberry Pi Pico W or a Pico 2 or Pico 2W, and I have it connected, in my case, COM25, and yours should look like this. If you're programming a Pico for the same time, it might say UF2. That's fine. Just know that when you upload the code, it will change if it's UF2. So now that we've written myHIRO.begin, let's just run the code as is and just see what happens. Give it a minute to compile there. What the code actually does is it defines all the servos, and once all the servos are defined and essentially attached, they all default back to 90 degrees. Once you run HIRO.begin and you want your robot to stand up, we're going to create a function called neutral stance. And you need to input your HIRO object first. Every one of the motion functions for HIRO takes in the HIRO object, so we called our HIRO object myHIRO. You can name the variable whatever you want. You can call it Steve, for instance. And I'm just going to write myHIRO here. And let's run the program. Give it a moment to compile. And HIRO stands up. So from the standing position, there's a lot of things you can do. Looking at the GitHub at the bottom, we should see some very useful functions. Let's try easy forward. Easy forward takes a HIRO object, a number of steps, and a speed. Let's limit the speed to 5 at most. I find a speed of 2 is the best. So I'm going to say easy forward. First of all, let's put the HIRO object in. Let's say it's taking 1 step, and let's say a speed of 2. And you guys can, of course, play around with this. So that was 1 step. It wasn't very much, so let's actually add some more steps. Let's say it takes about 5. Let's upload. Sometimes when you upload a new program, it changes the angles to some zany ones, and it takes 5 steps, and it finishes. Not very satisfying. Let's copy this over and put it in the loop here. Easy forward. Let's copy it again, but this time let's replace the word forward with backward. And let's run it. All right. Let me change the camera angle there so you guys can see. Backwards, forwards, backwards, forwards. Well, that's fun. But let's see if we can make it a little bit zanier. Is there anything in here that's fun? Okay, let's do a wave. So let's have HIRO walk forward, wave to the audience. And let's put myHIRO in here. and then walk backwards. And maybe HIRO should get a pause, so let's say delay, and maybe HIRO should wait about 3 seconds. So let's say put 3,000 in here, 3,000 milliseconds, and let's press play. HIRO walks forward, gives everyone a wave, walks backwards, and pauses for 3 seconds. That pause there is a little bit too long, so let's make that half as long, and let's also move HIRO back into a neutral stance. Remember, each time you use a motion function, you have to put the HIRO object instance in. Oh, no. When you do this at home, make sure that HIRO does not fall off any surface. So HIRO waves, HIRO walks back, HIRO stops in a neutral stance, and then pauses for 1.5 seconds. Okay, let's do something else. Let's make HIRO move in a square. So a square would be, HIRO needs to move forward, needs to turn 90 degrees, move forward, turn 90 degrees, move forward, turn 90 degrees, move forward, turn 90 degrees. So let's make HIRO turn right, so that would be an easy clockwise. Clockwise. As always, we input your HIRO's variable name, however many times you wanted to repeat the turn loop. So let's try 3. Maybe that's too much, maybe that's too little. Let's see. And so HIRO's going to walk forward a little bit, turn about 90 degrees, and turns about 90 degrees. Turns about 90 degrees. And HIRO has walked in a square. Let's unplug HIRO for a moment. So there are a lot of movement functions to play with, and a great way to actually check them out is by going to our previous example. Open examples, go to File, Examples, and go down to Serial Control. So this is a code example that we generated that uses most of the movements in the movement library. You can upload this on HIRO and play with different ones. So let's upload this. If the documentation on GitHub doesn't mean anything to you, because movement is such a visual medium, feel free to use the serial control example as reference. So far we've used easy forward, easy backward, as well as wave, as well as easy clockwise, and I think you can imagine what easy counterclockwise looks like. So there's a couple that you haven't seen. Let's open the serial monitor here. Let's go to Tools, Serial Monitor. It's actually listening for signals from HIRO, and HIRO is listening for signals back. So you guys have not seen side-to-side worm yet, which takes in a HIRO instance and a speed. So this is case number 6, so we plug in a 6. Okay, so I would actually like to use that in a custom program. So what you can actually do is you can go to your serial control, copy the function over until you get used to typing them out yourself. So our HIRO function has a different name, so I'm just going to change that to my HIRO. And let's just run this. HIRO is going to move forward about, I think 5 steps was a little bit too much. I was worried the whole time that HIRO is going to fall off the table. Let's have HIRO move forward about 4 steps, turn clockwise, do a side-to-side worm, move forward, turn clockwise, side-to-side worm, and see what that looks like. Move forward 4 steps, turn clockwise, side-to-side worm. That's fun. Move forward, turn clockwise, side-to-side worm. Move forward, turn clockwise. Oh, this desk doesn't work. This backing is in the way. Side-to-side worm, and it should continue over and over again as the program dictates. So in conclusion, the HIRO library is full of pre-choreographed movements that you don't have to reverse engineer to make HIRO fun. You can have HIRO execute certain motion sequences in response to sensor data, in response to signals from Bluetooth or even Wi-Fi. So use HIRO and use HIRO libraries to cut your robotics development time in half. Be sure to check out our next tutorial.